Okay, the first thing I want to do is review what we just finished talking about, and that is the product rule for exponents. When you are multiplying like bases, you add the exponents of the same base. So if you're multiplying like bases, you add those exponents. So the first thing we want to do is we want to be able to determine our like factors. So we have a factor of x, so we're going to find all of the, we're going to find all of the x factors. And then we have factors of y, so I accidentally did that one, so let's try highlighting over it. So then we have the factors of y. So as we multiply these, we want to add the exponents together, and remember, if there is no exponent, it becomes a 1. So the x is going to be 1 plus 4 plus 3, which means in my answer it's going to be x to the 8th when you add those together. And your y exponents, if there's nothing there, remember that's understood to be a 1. So we have 1 plus 5, and if I add those together, we get y to the 6th. So the product of xy, x to the 4th, x to the 3rd, y to the 5th is going to be x to the 8th, y to the 6th. Now on your worksheet that you have, you will be doing some problems like that. It's a review from last week. So the next thing we want to talk about in this particular lesson is simplifying by adding like terms. So like terms is almost like family. You want to make sure that the last name is the same. Now keep in mind, if we have families whose last name is Nelson, for an example, some spell it N-E-L-S-O-N and others spell it N-E-L-S-E-N. Now they're not the same family if their last name is spelled different. They're not going to be the same family. So we can only group them together if they have the same last name. So as we look at this, that's the same thing as simplifying by adding like terms. We want to make sure that that last name is spelled the same. So as we look at this particular examples, it's going to ask you to simplify by adding like terms. So we look at this, and the first thing we want to do is figure out what are the like terms. So as I look at this very first term, I have x squared y p to the 5th. Now remember, it is only a like term if its last name is the same, and that means it has to be spelled the same. So as I look at it, in the past we just wanted to make sure all the powers, they were just single exponents, so exponents to the first power. We just had to have the same variables. Now we want the last name to be spelled exactly the same. So if I look at this second term, the x is not squared in the second term, so it's not spelled the same way. So this is not a like term. If I go to the next term, the x is squared. We're good so far. We have y, that means y to the first power, and we have p to the 5th. Now the order does not matter because remember we have that commutative property of multiplication that says that you can multiply in any order. 2 times 3 is the same thing as 3 times 2. Now if I look at the last term, it is not a like term because we have an x instead of an x squared. So now we want to go through and say, okay, are the other two terms that are not highlighted, are they like terms? So we're going to look at this second term here, and I'm going to put it in a different color because it is not the same. So I have x to the 1st, y squared, and p to the 5th. If I look at this last term, I have x to the 1st, y squared, and p to the 5th. So it has the same variables, which mean letters, raised to the same power. So those two are like terms. Now if you remember when we talked about like terms before and adding them, we would add the coefficients. So we have a coefficient of 1 and a coefficient of 3. So I'm going to add those together. 1 plus 3 is 4. And then I keep those variables the same. The last name does not change. I want to keep that last name the same. Now I can rearrange the order of these, the factor of those, remember, because of that commutative property of multiplication. Now we look at the blue that has the same last name, x to the first, y squared p to the fifth, and I want to add those coefficients together. Take the sign that's in front of it. So as I work with those coefficients, I want to make sure I see that as a -7, and I have this +2, so that gives you a value of -5, and then keep that last name the same, x, y squared, p to the fifth. And this is your final answer when you simplify it by adding like terms together, by grouping like terms or adding like terms together. Now this is one on your worksheet. So let's look at another example. You might find out that this one is on your worksheet as well. Okay, the first thing we want to do is we look for the same last name, remember. Like terms. We are simplifying by adding like terms. So we have m cubed x y squared p. So if I look at the next term, it has the m cubed x to the first, y squared, and p. So the variables are the same, raised to the same power, so therefore that is another like term with the first term. So the first two terms in this example are like terms. Let's look at the next one. You have m to the third, x to the first, y squared, and p. So this is also a like term with the first two terms. Same variables raised to the same power. Now if I look at the last one, you have m cubed x, that x is squared instead of to the first power. So that means that that is not a like term, and that term is going to be a term by itself. We cannot add it to any other term in the expression here. So when we add them together, we want to add the coefficients together. So we have 2, +3, and -10. So you want to take 2 plus 3 is 5, and 5 minus 10 is -5. Then you have m cubed, keep that last name the same, x, y squared, p. So this is what we get when we group those yellow terms together. And then last but not least, we still have that last term. If you want to put a coefficient of 1 right there, you can, but it's understood to be there. So we could say plus y, x squared, m cubed, p. Now the order in which you write those variables down does not make a difference, but they have to be raised to the correct power. The order does not make a difference, again, because of that commutative property of multiplication. So we have another example, and this one will probably be on your worksheet as well. So we look at the first term, and I have x squared and y to the first. If I look at the second term, we have x squared and we have y to the first. So this is the same, it's a like term. If I look at the next term, I have x squared, but I have y. It's squared instead of to the first power. That means that it's a different term. So I'm going to highlight that a different color. That's not the same as those first two. So I look at the next one. We have x squared, y to the first. So this is a like term with the first two. If I look at the last one, it has x squared, but again, that has y squared instead of y to the first. That means that that is a different term, and if I match it up with the blue one, we have x squared, y squared. So that means that this is a like term with the other blue one that I have highlighted. So now we go through and we want to add them or group them together. When you do that, you add the coefficients. The first coefficient is 2. The next one is positive 3. And there is no number there, so we know it's understood to be a 1. And remember, you take that negative with it, so it's negative 1. So we have 2 plus 3 is 5, minus 1 is 4. And that last name, or what those terms are, that the variable part, is x squared y to the first. Now what we need to do is we need to add the blues together. So to add the blues together, we add the coefficients. Remember, this is understood to be a 1. I hope you can see that. So we have a positive 1, and we come over here and we have negative 4. So team negative wins by 3, or 1 minus 4 is negative 3. And then we tack on those variables. In blue, it's x squared, y squared. So keep that last name the same. And there is the simplification of that expression. Okay, I think I only have time for one more example, and this one does happen to be on your worksheet. So we look at this first term, 4xyz, and I go to the second term, x. I do not have an x. I know I have y to the first, z to the first, those match up, but since I do not have an x, that makes this a different term. So this is not a like term because the last name's not spelled the same. I'm missing that x value. Now if I look at the last term, I have x to the first, y to the first, z to the first. So this is a like term with the first term. So in order to add them together, we work with the coefficients. Remember, this is understood to be a 1. So we have 4 plus 1. That happens to be 5. And then I have x, y, z. You could put y, z, x. You could put z, x, y. And then this last term here, it's by itself, so we can just copy that term down. Now remember, because that term that I have in green or highlighted in blue does not have an x, it is not a like term. Okay, so for this week you have a simplified by adding like terms worksheet. There are 15 problems, and 6 of those problems are review from last week, which deal with adding those exponents when you are multiplying like bases. So it's review of the product rule for exponents that we talked about last week. Message me if you have any questions, and I guess that's everything, and I'll see you in Zoom meetings this week.